big thing we're going to kind of cover slant asymptotes, but we're also going to do a couple extra problems with graphing, just so we can kind of make sure everybody's okay with our unit with rationals is going to focus solely on finding different pieces about it and graphing it. So if you got your title in, you're good there. So let me just get you to all of the heads so you can write all that down. The goal with this chunk of a unit is no calculator the entire time, except on the problems for range where it specifically says these things. So when we do this and we're going through with graphing and everything else, I'll kind of force you guys to not use your calculator. You won't get your calculator on your test. Alright. So when it comes to slant asymptotes, and don't worry, I'll scroll it back so you're okay later. Alright, when we're looking at this, there's kind of a philosophy that we kind of... It deals with the law of large numbers. That much. Alright, we good? So for this problem, if you notice, we're only dividing the denominator by x, right? So we could potentially break this out and have x squared over x minus 3x over x minus 4 over x. And this simplifies down to x minus 3 minus 4 over x. So far, so good? Now, the idea with a slant asymptote, and the way I tell students to kind of view it is, all right, so you're down to this. This is actually your slant asymptote, but there is a small problem right here, okay? If you were to plug in, I don't know, what's the United States debt right now? Like $25 trillion? If you were to plug in 25 trillion, what would happen right here? What is 4 divided by 25 trillion? Stupid tiny, right? Essentially 0. So this basically disappears. So this is how you find your slant asymptote. Your slant asymptote is literally just y equals x minus 3. And you're done. Because the larger the numbers you plug in, that last one's going to drop off and go to 0. So it doesn't matter. Okay? So, do we want to do one that for sure has a slant asymptote, or do we just want to, like, kind of wean ourselves into it, practice, and then go for a slant asymptote on the next one? Wean into it. Okay. So, let's do this one. Alright, so take a second, write down the function, leave yourself this kind of chunk of space, because we'll factor everything there, and then write in everything on that right hand side. totally on domain for right now. Okay. So, step 1 off of our idiot's guide. What are we doing? So, if I look at the numerator, I've got x minus 2, x plus 1. I've got x plus 2, x minus 2. Crap. So, if you see me do something silly, like yell, large number division, large number addition, subtraction, I'm fine. For 6 minus 2 is 3 in my head today. So, alright, first step. Or second step, hold. Do you see a factor top and bottom? Where is it? Yeah, x minus 2. This is our whole. Alright, now technically that whole is actually at a coordinate. Alright, so a couple kids earlier today were like, okay, you tell me it's a whole at positive 2, but like where is it? So what I explained to kiddo first period is, alright, you know this is a whole. Let's play with the fact that we get rid of it. So I've got x plus 1 over x times x plus 2. Could you plug in a positive 2 on this bit right here? Because I got rid of the illegal things, yes? So, this becomes 2 plus 1, which is 3, or 2 times 4. So, 3 over 8. Like the actual coordinates for where that hole was. I always just in my head said, okay, at 2, when I'm drawing my line, put a little hole in the graph. Does that make a little bit more sense that way? Up next, vertical asymptotes. Alright, vertical asymptotes we find by whatever's left that's going to cause problems in the denominator. So I've got 2 of them. Where are they at? Other than 8. I'm going to call on somebody other than make everybody else happy. Somebody other than 8. Where are they at? What do you got? Yep, 0 and negative 2. So it's x equals 0 and x equals... As you're doing this, if you have an x equals 0 right here for a vertical asymptote, you will not have a y-intercept. Does that make sense? So this one does not exist. Because either a horizontal asymptote or a slant asymptote. So looking back at my original function, the degree up top, is that higher? Alright, so degree up top for my numerator, is that larger, smaller, or equal to the degree on the denominator? Smaller. So we said if the numerator is smaller, I have a horizontal asymptote. What in the crap? Look at that. Look at that. Come on. If I have a horizontal, I do not have a slant. Cannot have both. Okay. Up next is X-Intercepts. Alright, to find X, I always tell students, look at whatever's left in your numerator. Alright, so what's the only other 0 I'm going to have in that numerator? Okay. Flip the sign. Remember, you're trying to set this equal to 0. So I've got negative 1. Alright. Domain. Last kind of thing that we need to touch on. You have to take out any holes and any vertical asymptotes. So remember, we had 3. So this is going to be this big old string for my domain. Negative infinity to negative 2. And negative 2 to 0. And 0. And 2 to infinity. Basically, however many factors you have in the denominator should be how many unions you see. Union here. Union here. Okay. But we'll ignore. Want to try graphing it? So, when it comes to graph, and don't worry about putting a graph in your notebook. I have my graph stamp, which the blue kids think is factored to be x minus 2, x plus 1. Cool. And I just did a whole bunch of this. So, at 0, we said that was an asymptote, right? At negative 2, that was an asymptote. We had a hole at 2 3/8. Okay? Now we got a whole bunch of other stuff we got to fill in. Do we have a 0? Where was that at? Where were the x-intercepts at? Negative 1. Alright, so I know this one's 0. Cool. So I really only have 5 that I need to plug in, and I did way more points than we actually needed to. The reason I did that is because when you go to deal with all this, first of all, if these are the same top and bottom, when I go to plug stuff in, is there any point in plugging that in? No. So when I do it, I look at my simplified version of my rational expression. Okay? Then I'll go and actually plug stuff in. So if I want to plug in 1, I'm going to plug in 1 everywhere. 1 plus 1 is 2. Or 1, and then 1 plus 2. So I end up with 2/3 right here. See how it kind of leaves everything in factor or in a fraction form? Makes life a little easier. You guys plug in 4, and you guys plug in 3. Can you guys plug in negative 3? And can you guys plug in negative 4? And remember, just use this little red space. Is that a hamster ball? I have questions. Alright, make sure you talk with your people. I'm going to walk around and stamp stuff. Make sure everybody got the same thing you did. And when you guys think you've got it, go run up and write it in. Alright, you guys gonna go fill in the rest of that table. Rock, paper, scissors with who's going up. First period was just as chicken about it. No, I told them to do. Up there. You can use your finger too. Sorry, that wasn't the greatest. Then you're good. Thing's harder to write on than it looks, right? Alright, so, do we agree? It is magic stamp. Alright, so, let's do this. When I go to graph these, especially like the DNEs, I do those first. And you can either use a highlighter when you do them, you can use a colored pen, whatever floats your boat. But I try to make them like red, do not cross, Do not pass go. Do not collect $200. You set your foot over this line, it's getting chopped off. Like, do not touch it. All right, so I've got them at -2. Oh, come on. Give me back my lines. So when I do that, you can maybe cross it. It's kind of dependent on the problem, okay? Nope. Undo that last one. All right. Now we can start actually plotting points. So I've got -4 and -3/8. So like -1/2. -3, -2/3. Actually happening here is we are going to take a sharp dive. Next, you'll see that little curve, but you're not going to sit there and try to plug in -2.5 to figure out where it goes next. Okay? All you know is you cannot cross that red line. So it's got to go straight in. All right? Now in between, at -1, I have a 0 right here. But I don't have any other decimals. So there's a few different things that could be happening. And we'll graph it so we actually know what's happening. All right? 1 is at 2 is at 3/8, but there's a hole. So when you do it, actually draw like a little circle. All right? Just to delineate. Just to delineate that that's actually a gap in your graph. Okay? 3 is at 4/15, and 4 gets even tinier. I've got something that goes a little like this. Now, when it comes to your test, I wouldn't give you one quite this complicated, and if I did, I wouldn't make you graph it, simply because you don't know what's happening yet. All right, so there's a few different things that could be happening. I don't like this. You could have like this. You could have what looks like this. Okay, but you know there's a 0 there. So function was what? X squared the app that you can get for the Chromebook is such a pain, it's not even worth it. Like, I have tried using it a few times, and I'm like, I'd much rather this. Alright, so, here's my graph. See how it went straight down? And then this little chunk, it's such a skinny window that I would not give you something like that on the test. But now I know my shape, so I know it kind of looks like a backwards cubic, where it goes up that way, but what do we think? Not as bad, just kind of tedious. Okay. You want another one with a slant asymptote? And first period asked for one that officially had a y-intercept. Do you want that too? So, the one I've got came off of the homework. And it's all right, so I've definitely got a slant asymptote. Do you guys kind of want to try it on your own and see what happens? We're not there yet? No. Got a couple minutes. So, all right, what's step one? Factor. So this factors to be x minus 3, x plus 1 over x plus 2. Do I have any holes? Nope. You guys know what DNA means, right? Yeah, does not exist. Vertical asymptotes? Do I have any of those? Yeah, where at? Yep. I do. Okie dokie. Alright. So now we're down to horizontal asymptote versus slope, or slant asymptote. My degree on top is definitely bigger than the degree on the bottom. Okay? So what I'm going to do is I get to ignore that constant, but I'm just going to simplify by this x right here. So it ends up being y equals x minus 2. You kind of see how I did that? All right, X-intercepts. Do I have any other factors on the numerator that I haven't used yet? All right. So I've got an X-intercept at 0 and at -1. Now the y-intercept gets a little weird for people, but I want to show you guys a trick. So we did y-intercepts when we talked about polynomials, and we figured out that the y-intercepts were always at the constants, right? Whatever was left over at the end. So if I plugged in a 0 right here, that'd still be a 0. Plugged in a 0 right here, that'd be a 0. All I'm left with is that. Same thing on the bottom. 0 plus 2. So what I end up with for a y-intercept is 0, -3 over 2. It just comes from your two constants, numerator, denominator. Okay? So if Spidey is blue kids, right? Blue kids yesterday. I don't know what we did. All right, domain. Really, all I've got that's excluded is my vertical asymptote. So it's -∞ to -2 and 2 to positive infinity. That's a much nicer domain, right? All right. Last step is my table. So x is it plus 3 or minus 3? And remember, you guys don't have to go like 4 to 4 when you do it. It's just right now. All right. So what kind of stuff can I fill in on here? Where do I have an asymptote? At -2. I don't have any holes to worry about. Do I have zeros? Like, where are those bad boys? X-intercept. And then y-intercept we said was that. So I've actually only got 5 numbers. Like, okay. +4. You two want to take 2. You guys want to take 1. -3 and -4. Rock, paper, scissors, but who has to go write it up? honey, I've had some bad handwriting and I can still read it. People still bring me kids' homework from last year going, I have no idea what this is. Sorry, didn't have that great. Alright, so do you guys want to start graphing your asymptotes? And notice mine are already done up there. As I'm kind of looking at this is like -10. And are we sure this one's -12 or positive? Okay. No worries. We've got a little something like that. 0, 0. Stupid weird, right? Generally, when it comes to graphing and when it comes to me grading, I'm looking at this. I'm going to go, okay, do you at least have a couple points down here so you know that it's like a little loop? A couple over here, 2 right here. I don't care as much about perfection as I do know where all the pieces